let's talk about rigid inclusions. And oftentimes they're confused with piles, but if you could walk us through some of the common misconceptions of each and help us to spell out the difference.
They're often confused because they're pretty similar, really. The intent is similar. They're there to reduce settlement and mitigate. They could be steel or timber, but generally rigid inclusions tend to be concrete. And so piles have been around for a long time and people are pretty comfortable with them. And they may not be as comfortable or familiar with rigid inclusions. So it's kind of normal.
When it comes to construction projects, one of the most significant challenges is what we have to deal with sites that have poor soil conditions. The ground could be unstable, it could be weak, or it could be prone to liquefaction. And all of these make it difficult to build a stable structural foundation. That's where ground improvement techniques can come in. These methodologies can enhance the soil's properties to support the weight of the structure or infrastructure or building, reducing the risk of failure or damage. In this episode, I'm joined with Sonia Sorabella Swift, PE, and Director of Engineering at Menard USA. We're going to talk about rigid inclusions and piles and how these come into play for geotechnical engineers, how they function, and why they're essential to ensuring the safety and durability of buildings, bridges, and other infrastructural projects. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. And with that, let's dive right into today's episode. Sonia, thanks for coming on. How are you feeling?
Good. I'm feeling great today.
Excellent. Well, it's good to see you again. It's great to see you again, I should say. And it would be wonderful if you could start us out by telling us a little bit about yourself and what led you to become the Director of Engineering at Menard USA.
Sure. I graduated in 2006 with my master's, and I went to work at GEI Consultants, where I was for about 11 years. And there I learned a lot about geotechnical engineering and the construction industry in general. And I had a great teacher and mentor and champion, Mike Walker, and he was able to help me throughout, the early stages of my career and really pushed me to follow my love for rigid inclusion design and finite element modeling. And, it was kind of a niche area, and it was definitely growing, and we were trying to understand the behavior of the rigid inclusions with the soil. And a lot of it was kind of new stuff. And we really had to think, like, there was no cookbook way to do it. There was no code to follow. And so I really fell in love with all of it. And that ultimately led to me to joining Menard in 2017 and kind of taking on a more leadership role within the engineering team at Menard, where we kind of went from having a few in-house designers to doing all of our design in-house. And now there's about 25 people across the country doing design full-time, day-to-day. So it's been a fun ride.
Excellent. That sounds wonderful. So if you could kind of fill in the blanks a little bit, let's talk about rigid inclusions. And oftentimes they're confused with piles, but if you could walk us through some of the common misconceptions of each and help us to spell out the difference.
Yeah, I mean, they're often confused because they're pretty similar, really. The intent is similar. They're there to reduce settlement and mitigate and provide bearing capacity or enhance bearing capacity. And they're rigid elements, usually made of concrete, steel. They could be steel or timber, but generally rigid inclusions tend to be concrete. And so, they're often confused with a precast or an auger cast pile. Piles have been around for a long time and people are pretty comfortable with them, and they may not be as comfortable or familiar with rigid inclusions. So it's kind of normal that you kind of look to something, to try to understand something that you may not be as familiar with. But, and so they are very similar, but there's a lot of differences too. And But because of the similarities and kind of the comparison with piles, there are some misconceptions about rigid inclusions and how they behave and how they should be designed. And one of those is that rigid inclusions are piles. And so they need to follow, the codes for piles, and they need to be designed and installed and tested the same way that a pile would. And in some cases, that may be true. And we'll get to that in a little bit. But there's a lot of cases where really that doesn't apply. There's a lot, one of the other things that people don't often realize is that the rigid inclusions are sharing load with the soil. And so there's a lot of variability in the design that needs to be taken into account because of that load sharing. And I think the other misconception that I've seen kind of stick throughout the years is that the rigid inclusion designers are performing these designs using some obscure technique. It's a black box. The results are magic or voodoo, and no one could possibly understand it or check it. And that's really not the case, at least not at Menard and many of the contractors that are doing this nationwide. But the designs are complicated and they're iterative. So it's not really efficient to do it out by hand. It's really time consuming. You really need something like a finite element model or Excel spreadsheet, something that can iterate to find the right solution. So it's really hard to provide something that isn't just output and that really explains what went into the design. But I would encourage anyone with questions who's reviewing a design or trying to understand how it works to just ask. Most of us love talking about how rigid inclusions behave and how they're different or similar to piles. And usually that helps more than a few pages of calculations would.
Love it. I love it. All right, cool. So we talk a little bit about the misconceptions. Let's talk about some of the main differences between rigid inclusions and piles, and how do those differences affect how they're used in practice?
Yeah, so some of the main differences are that piles are connected to the superstructure. So you have a physical connection to a building, for example. The piles would be embedded into a pile cap and a structural slab. Whereas with rigid inclusions, they're separated by a load transfer platform, and that helps distribute the load to the soil and the rigid inclusion. So then rigid inclusion supported structures can use spread footings and slabs on grade as opposed to structural slabs and pile caps. And that generally, even when you factor in the cost of the load transfer platform, it generally provides a significant cost saving. The other big difference is the allowable settlement. A lot of times with pile projects, you're looking for 0 to maybe half an inch of settlement. With rigid inclusions, typically we see 1 inch, but often we do see up to 2 inches of allowable settlement, depending on what the structure can tolerate. So there's a little bit more to work with. And there's, the team needs to be aware that that additional settlement could occur.
Excellent. Excellent. And I know you recently wrote a paper on rigid inclusion, or the rigid inclusion spectrum, called Rigid Inclusions, a Spectrum of Applicability. Can you explain that concept of spectrum of applicability and how does that apply for rigid inclusions?
Yeah, so this spectrum of applicability is something that I've been using for years to kind of describe the range of projects that you could apply rigid inclusions to. You could use them for settlement mitigation only on a site with pretty good soils, low loads, but for some reason, stone columns or some other less robust system can't be used. Maybe there's a thin layer of organics, maybe it has to do with noise or vibration or whatnot. And so typically in that situation, the risk is fairly low and you'd fall on the left end of the spectrum. Then on the right end of the spectrum, you could have a site with high loads and really, really soft soils. And the rigid inclusions are providing settlement control and they're providing bearing capacity for the structure overall. And so in that case, they are behaving more like piles and you are on the right end of that spectrum. So the design for them at that point needs to be a little bit more thoughtful and thorough. And you just have to change the the methodologies that you're using and kind of the mind frame it, and not use some of the ground improvement mentality that we have when when the element is really going to behave more like a pile. But between those two ends, there's a vast amount of projects
Yeah.
and combinations of soil conditions and loadings and tolerances that the structure can have, or the allow the settlement that the structure can tolerate, that all impact where you would fall on the spectrum. And as you move to the right on the spectrum, you're increasing in risk. And so you should also be increasing in conservatism in the design. So you kind of have to consider what's going to happen if the rigid inclusions don't perform as we expect. What's the risk? And the project team really needs to be involved in that discussion. That's one of the things that I think is important. Is it's not any one person's job to place the project on the spectrum, because everyone has a say, and everyone will have to live with whatever the result is or the conclusions are. And so if you are closer to the right side of the spectrum, it doesn't mean you can't use rigid inclusions, but you have to think through the design and understand how the element's going to behave. If you're somewhere in the middle of the spectrum, you have a little bit more flexibility. You can probably optimize your design a little bit more. The designer, the engineer of record, really can make a lot of decisions on what factors of safety to use and how much conservatism to build into their design, based on, again, that risk tolerance and that understanding of where this project, that there is some flexibility. We are in the middle of the spectrum. It's not acting like a pile.
Got it. So if I'm listening or I'm watching this podcast and I'm a project reviewer or I'm an engineer of record, like how does somebody decide where they are on this spectrum? You said it's the team that, a lot of people come together, but how do you decide?
It's pretty qualitative at this point. I mean, it would be nice if there was a scale or a numerical way to kind of gauge where you are. And so
Yeah.
it might be difficult to do that and to kind of place a project on the spectrum without some input from the rigid inclusion designer. But they can look at a project and start talking about what factors may impact the location on the spectrum. I think people need to look at soils, particularly soft soils, bearing pressures that are higher. So, anything above 6 KSF, seismic forces and seismic loading, that would move you to the right a little bit. Settlement that's unusually stringent, anything that seems like it's not your run-of-the-mill project, or you're trying to push it a little bit with higher bearing pressures, or unsupported settlement. If your unimproved settlement is in excess of about 4 or 5 inches, you really need to start thinking about where you are, because chances are you're further to the right on that spectrum. A lot of times it's not as concerning when you're on the left half of the spectrum, but recognizing that you're on the left half of the spectrum means you can use that ground improvement mentality to both design and review it. So again, it's qualitative and it's a team process, but I would say that, soils, loading conditions, seismic loading, those are kind of should be triggers to think about, how is this really going to behave in the field.
Got it. All right, cool. And let's see, in your experience, what are some of the benefits and challenges of using a load transfer platform with rigid inclusions, especially when you have projects that have high bearing capacity requirements or settlement control and variable soil conditions? And covers a wide range of things there, but what are some of the challenges you've seen?
Yeah, I mean, using an LTP or a load transfer platform, it's pretty common, and it's kind of what's associated with rigid inclusions is that you have this platform, and there's this separation between the structure and the top of the rigid inclusion. It provides a nice buffer. It helps distribute the loads. That's its primary function. But it also, makes it less critical to have the top of the rigid inclusion exactly at a given elevation. So it provides the contractor a little bit more flexibility when they're, putting in the load transfer platform above. And so it's beneficial. But it's also kind of a catch-22, especially with projects with really soft soils, because the thicker your load transfer platform, the more settlement you're going to get, because it itself will compress, but it's also going to help distribute load to the soil and put load to the soil, so that soil will lead to larger settlements. So a lot of times when especially high bearing pressures are applied on sites with really soft soils, everyone likes to thin up the LTP or get rid of the LTP completely, which you can do, but it then becomes you're then on the very far right of the spectrum, and you need to evaluate everything on the project from the rigid inclusion to the slab and the footing as if it were, supporting a pile, or as if it's getting these loads directly from the rigid inclusion, because it will. There's really nothing to distribute that load anymore. And so that's kind of the real challenge, especially with slabs, thin, unreinforced, 5-inch, 6-inch slabs. Putting a rigid inclusion under that may mean that you need to thicken that slab, add some steel, add some fiber reinforced concrete slab, which we've seen to be really effective in those cases. It can be done, but you can't ignore it and just say, oh, it's rigid inclusions, it's ground improvement, we don't need to worry about that. And that's kind of knowing your place on that spectrum and addressing any unintended issues or consequences that may come of the decisions that you're making.
Got it. Okay, let's switch gears a little bit. So communication is super important in all things that we do, right? But communication and collaboration with all the different parties in a project, what are some of the strategies that you found that are effective when fostering strong teamwork? And I know that's got to come into play when you're entering a project.
Yeah, it definitely does. And it's actually pretty much the same thing. I mean, it's communication, right? And it's open lines of communication within the project team, and being able to say, hey, we should really talk about this. Everyone's busy. It's hard to pull everyone into a meeting. But generally on a project, there's some key items or questions or concerns that each party brings to the project, right? And so understanding what is important to each person on the project or each team on the project will make it easier for us to address issues down the road. It'll make it easier for us to explain what the elements are doing and understand, what's really important to them. Is it the cost of the load transfer platform material? Is it, accessibility of this material because it just doesn't exist in this area? Do we need to change how we're looking at it? Is it really settlement performance? Has someone had a bad experience with rigid inclusions or some other kind of ground improvement? And so it helps bring all of those things out into the open for a discussion. And it doesn't have to be, hours and hours and hours. It can be a conference call that lasts 30 minutes, but it may make a huge difference to just understand what's going on, who has what questions, and, just answering them either then or kind of being aware that they'll need to be answered during design.
Got it. I appreciate that. It's so important. I mean, this is technology that's familiar to you, but sometimes you work with a client that they only know piles, right? And if we don't have open lines of communication, we're going to miss something. So
Yep.
that's really awesome.
And things are always changing too during projects. A
True.
lot of times with rigid inclusion projects, we're either an alternate, so we're coming in late, or, for some reason we haven't really had access to the whole project team. And so the quicker we can understand what everyone's issues or questions are, the quicker we can address it so that things aren't coming up while we're in construction as a surprise and causing a lot of stress and frustration. So definitely important in that respect.
Really good. Really good. So before we take our break, final piece of advice you want to give to engineers that are looking to deepen their expertise and foundation solutions, especially as it relates to rigid inclusions and piles?
I guess asking questions and having an open mind as to how the system will behave and how it can be optimized. The beauty of rigid inclusions is really that you can optimize them and take advantage of the soil on good sites. And so you can end up with a leaner solution, install less elements or less deep elements. It's good for cost, it's good for schedule. It's also great for the environment and is a much greener solution. And so, that optimization is worth something. And I think keeping an open mind and looking for conditions where you can do that optimization is really important. But asking questions.
Excellent. All right, great. Well, thank you so much. We're going to take a break. We're going to come back in just a minute and close this one out with Sonia and our career factor and safety end segment. Stick around. All right, welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. Well, what about incorporating a factor of safety into your career? Today, of course, we're speaking with Sonia Sorabella Swift, PE and Director of Engineering at Menard USA. So, Sonia, you've had already a very successful career. But when you look back at your career, what's something you've implemented to, let's say, call it a factor of safety in your career?
I've implemented or used my love of people and psychology to kind of help me. I love thinking about why people are doing something or saying something or what motivates people differently. I love reading books about emotional intelligence and all of that. And so I try to be really authentic with the people that I work with and that I manage just in general and kind of really get to know them and play to their strengths or their weaknesses in the sense that I'm always thinking about them as a person, not just as an engineer or an employee. And I think that's helped and that's brought a lot of fulfillment to me personally and kind of seeing those relationships develop over time. It's also been kind of nice that I've been able to be involved with training and education programs at Menard. And so, running technical seminars or trainings every month, which we do, but also being involved with thinking about how to train people from a leadership standpoint and a management standpoint and how to, sprinkle in some emotional intelligence and all of that in between all of the technical stuff too. So that's been really nice. And it's allowed me to have a little bit of a break from the technical thinking.
Fantastic. Now, I could tell you're an excellent leader and you're pouring into your people. So that means a lot. So thank you for your leadership. All right. Well, thank you so much for coming on. You shared so many great insights. And this is great information and advice that's going to be helpful for our listeners. If somebody wanted to reach out to you, what's the best way for them to find your social media, the email you want to share? We'll put in the show notes.
Sure. Yeah. My email is the best way. My email is sswift@menardusa.com.
Okay. Excellent. Well, thank you so much for coming on the show. This was really great.
Thank you. It's been a pleasure.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. Please feel free to go to geotechnicalengineeringpodcast.com where you'll find a summary of the key points discussed in today's episode, as well as any links to any resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.